What's happening, dogs? Mr. Allen here. It's time to start talking sequences in this video. We want to write recursive and explicit formulas for each one of these patterns here. I've got number of blocks in this one here, and then with our geometric shapes, square, hexagon, octagon, number of sides. Let's start with the one up here in purple, number of blocks. What's happening? I start with 2, then I have 5, then I have 8. We're going up by 3. It's pretty clear that you're going up by 3 each time when you start isolating these little parts. So I'm going up by 3. That means that I'm dealing with an arithmetic sequence since I'm going up by a common difference. So I'm going to write down arithmetic here. Arithmetic, and D is equal to 3. We said our common difference is 3. So for a recursive, it deals on the previous term, which means I need to write down my first term. So we're going to say that a sub 1 is equal to 2. And then I can say that a sub n is equal to my previous term, which is a sub n minus 1, plus my common difference of 3. This is the recursive formula, okay? So recursive relies on the previous term or the previous 2 terms. It can get kind of crazy, but this right here, when we say a sub n minus 1, we're just saying, hey, the term before the one you want. If I said a sub n minus 2, I'd be telling you to go back 2 terms from the one we just had, okay? So if I take the term prior, which is 2, I'd add 3 to 2 and I get 5 for my next one, so on and so forth. Okay, that's how recursive works. So this is recursive. Recursive. Kind of tiny there. All right, explicit time now. So I'll actually label this one explicit ahead of time. Now, it's still going to be a sub n here, okay? But we're going to have that first term within, all right? So my first term has 2 blocks, right? And it can be helpful sometimes, even though we saw the common difference here, to write down like 2, 5, 8 number of blocks if you don't see it right away, okay? So a sub n plus, and then it's going to be my common difference of 3 times, and then we'd have n minus 1. So your explicit formula for an arithmetic sequence is your first term plus your common difference times the n minus 1. And we can actually clean this thing up if we'd like. Distribute the 3n. Let's see if we have enough room here. So we'd have 2 plus 3n minus 3. And then I can combine those 2. I'm just going to bring this up here. And I'm going to have a sub n equals 3n minus 1. So this is acceptable. This right here is also acceptable for an explicit formula for this number of blocks up here. Beautiful, man. We are cruising. All right. Down here with the geometric shapes. Number of sides. I'm going to write down my number of sides here because it's a little less obvious with like counting by the blocks. So for my first one, I have 4, then I have 6, and then I have 8. And some people also like to write down their term number, like 1, 2, 3. Sorry, that kind of got a little crowded over there, right? 1, 2, 3, 4, 5. Because we could also say like, how many sides are going to be in the fourth one? Well, that'd be 10, right? I'm adding 2, as we see from 4 to 6 to 8. I'm adding 2 each time. It's arithmetic, isn't it? Arithmetic. My common difference is 2. We've just said all these wonderful things, right? I can ask you to find another term later on. You know, we'll do that here in a sec. Let's write the formula, and then we'll go beyond, okay? So my recursive, okay, we'll start with our recursive here. We got our a sub 1. How many sides do we have for a sub 1? We have 4 sides. It's a square right here, right? So then a sub n is going to be my previous term, a sub n minus 1. That means the term before the one I want, because I want a sub n. We're going to go 1 back from that, plus my common difference of 2. So if I take the 1 before this, that's 4, plus 2 gives me the 6 sides. If I want my third term, I got to go 1 before to this guy, 6, plus 2 gives me the 8 sides. Cool? Recursive. All right, now explicit. So this one is just a sub n, and then I'm going to have my first term, which is 4, plus my common difference, which is 2, times n minus 1. And if we clean that all up, we will get, I know I'm running out of room here. Hopefully we can see it. Let's see, we have 4 plus 2n minus 2. Combine those, we get 2n plus 2. Where do we want to write this? I'm going to write it in here. A sub n equals 2n plus 2. That is our simplified explicit formula. Some teachers like you to simplify it, clean it up, if you will. Some are cool with you leaving it just like that. Dang, dude. That's awesome. So what if I said I wanted like the 6th term, right? In this pink one here, in the number of sides, the 6th term. Well, I could like count it out and just keep counting by 2s, or I could throw 6 in here. 2 times 6 is 12, plus 2 is 14, 14 sides in the 6th one of these patterns here. I could go to the 100th, right? Nobody wants to count by 2s for 100 times, right? So if I want the 100th shape here, how many sides is it going to have? 2 times 100? 200. Plus 2? 202. Easy peasy, right? So there we go. Recursive, explicit. Remember, recursive relies on the previous one or previous couple, if it gets crazy. And then explicit is just like your normal formula. It does actually look like a linear equation, doesn't it? It is. All right. So that's it. See you dogs later.